Hare Krishna friends. Today we are going to start a new chapter, that is your tensors. So we will talk about in details what is tensor and different types, general tensors and tensors in different coordinate systems and more. Okay. So let's start with tensors. So what do we mean by tensors? Let me clarify few things before going into the topic. Okay, first of all, you remember that I have followed 2 or 3 books to teach you this topic. Okay, so I would like to suggest you some books. You can read Arkin, and there is another book Walker. And for basics, you can if you are studying it in your VSc 3rd semester or 6th semester after vectors, you can consider HK Das also. That's also a good book. Okay. So in order to study tensors, what do I mean by tensors? Okay. You might have known that scalars, we can also call scalar as a tensor, but it has rank 0. Okay. And we call vectors, you have studied in your graduations that vectors are also tensors of rank 1. Okay. So here we will be focusing on the tensors of higher order, from starting with tensor of rank 0 to high dimensional order. Okay. Next we will see its applications in different topics like quantum mechanics, electrodynamics. Okay, we will see in details. So tensor generally means it's a mathematical nomenclature or a mathematical tool to describe the physical quantities in a system. Okay, this one you can refer the Arkin for the detailed definition. I would like to say you that if you are following my lectures, there will be no requirement of any books. Okay, but for problem practice you can choose any book of them. Okay, so let's dive into more about it. In before starting tensors, you have to know few things. That is your I will discuss basically this class would be referred to your pre-tensors requisite. Okay, so basically we're going to discuss about your repeated indices. Okay, so what does repeated indices in tensor we represent? So repeated, you might have known that this kind of thing. Okay, when you are writing an infinite series or few series like things, you have noticed that these kind of things, in order to write these kind of things, we use summation. Okay, we use summation. So Einstein, what he did in his theories or in his papers, he used only these terms. Okay, generally he neglect this term. So this becomes just AIXI, where your I varies from 1 to n. Okay, this is, we call it a universal range of summation. In order to write that many terms, okay, we are minimizing these as your summation, and in order to write the repeated indices in sums, we write like this. Okay, as I have written, you can refer to this. Okay. For example, I have given here that you can consider here. See, here are I 2 times and k, and you have given that I varies from 1 to 3. So what you have to do is, in place of I, put 1, then 2, then 3. So here I comes 2 times, so I have written A11 xk, A22 xk, A33 xk. Remember, if I will say that k also varies from 1 to 4, then you might have written A11 x1, A22 x2, x1, A33 x1, and then second A11 your x2, then similarly x3, then similarly x4. Okay, likewise you have to write it like this way. Okay, and next example, you see here I have written Aij xj. Here repeated indices is jj. So and its value varies from 1 to 2. So how I will write it like this: a I1 x1, a I2 x2. Okay. Next is our free and dumb indices. These term you are going to frequent use. Okay, you are going to use it frequent. Okay, so remember, what do we mean by free indices and what do we mean by dumb indices? Very important concept, and it's a simple concept. Okay, see, a IR XR and a IV XV. Okay, see, I have an expression like Aijxa. In previous slide, if you see, if I have written like this, Aijxa, here J is the repeated indices, and you see here I have written Aijxa. In case of your J, I have placed R, and I can also write V. Okay, these are called the domain indices. Okay, J is called the domain indices. That's why I can replace J and write any other indices. Domi means its photocopy types. Okay, and I is called the free indices. I is called a free indices, and because I is counts only one times, that's why I am calling it a free index. Okay, see a question I have taken here: if n is equal to 3, write down explicitly the equations represented by the expression yi is equal to air xr. Okay, see, you have to write the explicitly the expression. Okay, see, if here mark one thing, that r is your repeated index, or you can say domain indices, and I if I will write I keeping constant, keeping summing over I, then I can write it like this. In the next slide I have written, see, yi I can write ai1 x1, ai2 x2, ai3 x3. So now if I will vary I from 1 to 3, I can write it y1, y2 and y3 like this. Okay, simple things. Okay, I am doing these things because you might have forgotten the things in your BSc level. Okay, so it will be a revision for you. Okay, and the new concepts you have to memorize those things, that is free indices, dumb indices. Okay, and the repeated indices, how to explicitly write the equations. Okay, these are going to be very much useful in writing the tensor quantities. Okay, we'll see in details. Next, we have Einstein summation convention, a very important groundbreaking thing. This one is Einstein summation convention. So what does Einstein, as I have told you earlier, that any expression involving a twice repeated index, that is your, if it is a subscript like C, xi, this one is the superscript, xi, this one is the subscript, and if I will write xij, this one will be called as mixed. Okay, neither it is subscript, neither it is superscript, it is the combination of both superscript and subscript. Okay, so these, if one indices, that is I, if I is repeated twice, okay, so shall automatically stand for its sum over the values 1 2 3 till n of the repeated indices. Okay, and note here, here is a remark you have to remember, that no indices may occur more than twice. You can't write xii and you can sum it like your Einstein summation convention. For Einstein summation convention, you must have 2 times, not more than 2 times. Okay, repeated indices. Okay. Next, you see, I have some of the problems for you. I will solve in this class also. Let me solve it for you guys. Okay. Okay. With me, you are also try to solve these questions. Okay, the first question is like this: you have to write explicitly the summation ci xi plus yi. See, how can I write it? Xi plus yi, and you have given n is equal to 4. So I can write it like this. See, c1 x1 plus y1 plus c2 x2 plus y2 plus c3 x3 plus y3 plus c4 x4 plus y4. Okay, like this I can write. You can also multiply it and write it again. Okay, this is the simply thing. I have only taken this example because to understood you, that is explicitly the summations how to write. Okay, see, the second one is use the summation convention to write the following system and indicate which indices are free and dummy indices. Fix the value of a. See, in this example, what happens? You have given with some expression like this. Let me write it for you. You have given this d b1 j x1 plus b2z x2 plus b3z x3 b4z x4 is equal to bz. You have to show this. Okay, you have to find. Okay, you have to find the free indices and dummy indices in this expression. So in order to find this, you see, how can I write it in summation? See, I can write it like this: bij x xi xi is equal to your vj, isn't it? See, I is getting changed 1 2 3 4. Similarly, x has the subscript 1 2 3 4. So I can write I in place of this changing basis. Okay, so and here j is given. See, here j is given here 1 to 2. Okay, you have to simple write it as j is equal to 1 2. Okay, this is how you write the summation convention. And the free index is here. What is the free index here? See, you can see clearly that the free index is j and the repeated index, that is your dummy index, is dummy index. Dummy index is what? I, isn't it? Yes. See, okay, let's see Kronecker delta. You have already studied in your mathematical physics and let's say your quantum mechanics, you have studied Kronecker delta, but we will see the physical significance here and its properties, okay, and its use in frequent cases of tensors. Okay, let me say how do we represent and how do we understand by the definition of Kronecker delta. So by saying we represent it as del ij, we can also represent it del I. You have taken subscript j and superscript I, and you can also write it in superscript ij. Okay, so it signifies that I is equal to j. When I is equal to j, you have the value 1, and when I does not equal to j, you have the value 0. And you can also say that is for all I is equal to j, your del ij is equal to del ji. This one is a very important property we are going to use in many problems. Okay, in many question solving we are going to use. So remember this. Next, I have taken an example. If n is equal to 2, del ij xi xj is equal to, how do I write it? See, n is equal to 2 is given, so del 1 1 x1 and x1 plus del 1 2 x1 x2 del 2 1 x2 x1 del 2 2 x2 x2. I have just putting the values ij and that is n is equal to 1 and 2. Okay, and you see the values of del 1 1 is 1, del 1 2 the indices I does not equal to j, so I can write 0 0 multiplied this is 0, del 2 1 it's also 0, and del 2 2 is 1. So we are getting with x this first term and last term, that one is x1 square plus x2 square. So this is how we use Kronecker delta in order to find the summations. See, next some identities we can't use, like some algebraic functions we can't use. See, aij xi plus yi, I can't write it like aij xi plus aij yj. Okay, if it should be yi, okay, you can write it as yj. aij xi yj, we can write it like aij yi xj. If it should be your, I have written aij xi yj, if given you can write it like aij yj and xi. Here the mistake is I have changes the basis. Okay, you don't have to change the basis. If you change the basis, the identities will not be same as before. Okay, and the next one is a ij plus a ji xi yj. You can't write it like 2aij xi yi. You have to write it like this. Okay, the third one you have to like write it like this. Okay, so next we have if I have a problem for you, express bij yi yj in terms of x variables if yi is equal to cij xj and bij cik is equal to del jk. Okay, see, I have this question. You have to write it in the terms of x variable. Okay, for this I have taken yij is equal to cij xj and I have taken bij cik is azure del jk. So in place of yi yj I have put the values. See, here I have taken jj. These are the domain indices, so I use r, okay, in place of j, and in place of your yj I am using cj, and the domain indices j is represented by your s, and bij cir I have taken it into one bracket, and I have done with xr cj's x's. So next you have this term, you can write it as del jr. Why I can write it like this? See, the Kronecker delta definition, you can see that del jr here I and I, that is the same indices, so you can write it as del jr, and you are left with xr and cj's x's. And one more thing, here I have written del jk as this, so you can refer to this also. Okay, why I have written del jr here? Because bij cik is equal to your del jk. Okay, that's why I have written it like this. And next you have xj. In place of del jr xr you can write xj. Okay, I have minimized this to xj, and cj's x's as it is. Ci, so I can write it as cij taking to the first and xi and xj. See, in place of s I have used j here because s is a domain index. So in case of a domain index I have used another domain index, that is j. So this one is the final answer. This is in the form of x variables. Okay, in the form of x variables. Okay students, for your convenience I have attached some of the problems question. Okay, you can refer to this, you can solve, and you can join my Telegram channel. We can discuss the problems there. Okay, the questions you don't have the answers, I would like to say that you can join my Telegram channel, and there join the Telegram. Okay, in the description box I'll share the Telegram channel. Okay, and there you can find the answers. I'll upload the PDF of the tensor. Okay, there you can access to it, and in the next class we'll be going to the next chapters in this section. Okay, so do like, share and subscribe. That's what I would like to say. Thank you for watching. Okay, keep supporting.